small enough. So, up that bearing stick. I really do. I mean, for less than $100, which is what I got this one for. I just want this to go in the groove. If I can get it in the groove, then I'm good. Round, big machine and tension. If it works quick. So, okay, well, that was easy. Basically what I did, I should have filmed it, but I never do when I do these things. I took one of my old Makita sprockets. You need this driver part. There's a partner to this spline underneath that has a spring that pushes up against. This catches. If you spin the thing forward, you're not catching the shaft. So when that spins on the shaft, there's a spline in there that drives that. That actually turns the hub. So the other hub that came with this kit for the Husqvarna saw, I just pulled this out. You have to squeeze this down. You have to depress this clutch, and there's a little ring pin in there. You have to pop that ring out, and everything goes flying across the room. So I popped those out. I was going to reuse those and try to squeeze them back, but it's all different heights here. So I just decided to weld it. I welded, it's basically the shaft and this spline is all one piece. Or this catch here, it's all one piece. So I just slid that in and it fit the board perfectly, so I just welded it. And this works. This actually worked. This is another one of those things that I try out. I try out for fun. I try out as an experiment. It's a one-shot deal. If you ruin the one, you're kind of out of luck as far as continuing the experiment. But it works. Slightly underpowered. I was going to try it with the newer saw, but I don't have any sprockets for that saw. It's the same configuration, but it's a little bit different setup. It's different sizes and different measurements. It turns the bit enough so that I can make some bowl shapes. My holder for this so it's easier for me to cut bowls without the piece of wood moving around. So this is going to evolve. We're going to work on this some more to improve it. For now it works really well. Okay, so that's really cool. Look at all the huge chips this thing. I mean, you could use a saw to do this, but this is faster and it's easier. It's more efficient. It takes out more material faster. I'm cutting only clean wood with it. A lot of the other people that I've seen test them out, they're trying it on bark, they're trying it on bigger logs that might have some dirt in them. I'm not finding any problems with it. That's why I want electric, because now with electric I can put them like this. And you see it does like to catch. We'll get more into this. The head's a little warm, not too bad. Saw is warmer than the head is, because it's a small saw. It's working hard. But all right, so we're in a bit of a bind here because this saw is old. It's wiped out. The bearings are screaming on it. It gets really hot when I use it with the rotary gouge disc thing. So I took it all apart. It's very simple. It's really very simple. I mean, you can't go wrong here. Everything is reverse threaded on this thing. That means all the threads are backwards because of the rotation. And what I wanted to do here, I'm just trying to think up. I'm trying to devise myself a mechanism. What I wanted to do was initially what I wanted to take the pulley off. I wanted to eliminate the pulley drive. The way this goes in, you can't really switch this to get it more centered on the inside. I mean, I've tried everything with this, basically, just for fitting stuff up. But this is basically your, this is pretty much your whole thing here. As soon as you take this off, or that, you take this side off, this whole side falls out because it goes in this way. So these are pretty simple construction, pretty good quality for what they are. There's 2 bearing cartridges pressed in here, and it's just held in by this clip ring, so you can replace these. Not the biggest deal. There is a number on them, just like with a skateboard bearing. It's basically a skateboard bearing, or a bicycle, a sealed bicycle wheel cassette bearing. Now the thing with this is, I instantly said, oh, I'll just slap it on my angle grinder. Well, there's part 1 of no, because now if you're going to throw it on an angle grinder, see that spacing there? You're going to have to grind down this to get that to press on, and angle grinders go this way. So already we're screwed. I guess it would work this way, but I mean, man, you're pushing the limits here. You see how close tolerances, then you got to screw around with spacers. You got to sit here and, all right, so I'm going to try putting that on there. Let's see how that works there. And you know, now it doesn't all screw down very tight. There's barely any threads here. To get this to work on an angle grinder, I mean, it would work. That's the whole thing. But you're going to have to do a lot of messing around to get this to work anywhere. So that's pretty much the dilemma that we're in right now. Because if I go here and I go to any, what my idea was just to put a chainsaw sprocket for running chain saws. I want it simple. I want it all so I can just switch and swap stuff out. Here, yep, we're already not. You know, it looks the part, but it's not. It's a different part. See, that one's bigger, or that one's smaller than this one. This guy threads here. Okay. So you're doing a lot of this back and forth and nothing fits. Let's try a rim sprocket. Yep. So it's just a matter of, it's a bunch of playing around that you got to do now. The idea is to get a chainsaw sprocket on here, because you can use a chain to turn this thing. If you were to if you were to knock all the teeth off a chain, that's how the old log wizards used to be powered. You just knock all the teeth off. The problem with it was, see, and that doesn't fit the steel sprockets at all. The problem with it is getting it to fit any saw easily. This one came out pretty good. This one still has a little bit of, but that's okay, that'll burn out. But I really like this. And see, this is what I'm really trying to go for. You see this different from the saw. You see the difference. And that's, my saw was, you know, I took the teeth way down on it too. That's actually the little 43 thousandths chain, the little fine stuff. But here, what I like about this is the width, because it just makes such a nice, like, chisel mark. Okay, so I was able to very lightly and gently grind that out and tap it out. I welded it a little heavy. This I used just the Dremel. These are the quick release little cutting discs on a rotozip, variable speed. That way you're getting the horsepower, but you can also slow it down so it's not burning your disc up. Very gently, took my time, came right out. No damage or. So this is the difference. The Husky sprocket is flat on top. That I would rather use that for this application. Just because that way I don't have to really modify anything. I don't have to mess around to get those pins, to get those washers to sit flat or work right. Here I can probably just put it all together and hope and pray. The outside of this hub doesn't matter. You could get rid of this entire thing actually if it's getting in the way of anything. You could cut it right off just so you have the pulley and the drive unit. So now is the fun part, where we get one of these and we got our 2 blocks, and we got, let's see, let's put our drive washer on there first. Get that in as tight as we can. It's this washer that's critical to this whole operation, because you see it's got a bevel in it, it's inset, so it's going to allow for everything else when I compress it. So we're going to try it. I got to get all this to go down all dead flat, and hopefully I'll have enough room to get that washer. And this is all, we're not dealing with anything precise or exact. Nothing is made to go with anything else here. So that's the issue in this whole operation. It's very experimental, and you're trying things out. Whatever works, works. Which is kind of cool. But you see, I got to have everything together here. Make sure the dang camera's in the right place so you can see. I got to have everything together, and then kind of snug it up, and then kind of open it up. And this just takes a lot of finesse and time and patience, and you might have to go through this step 9 or 10 times before you get it right. Because as soon as I start squeezing, it's all got to go down together in one hit. And I got to have room here to get my ring in, but I also got to be compressing the washers in enough. And I don't know if that's actually enough. I might have to remove something, try something different. I don't know. This is that phase where you're experimenting. So that's looking like that's going to be a problem. Okay, now I'm going to take and I'm going to show you. This is off of that UC 4000 hub. All right, so you have two washers, right? But you see the spacing difference? You see that when I flip the washer? Okay, so this is your spring, right? So these washers have a conical shape to them. They're not flat. There is a difference in shape. I don't know if you can see it real well with the camera. Okay, but you see if I put the washer there, there's a space around the outside. Okay, so the way these fit together is just stack them back to back, right? And then that all compresses, right? It all compresses down, and there's a ring. This is a notch washer. This is for the square notch on the bottom. This is the driver washer. It's this guy. There's an inset. There's a bevel in the middle of this that when you press all this together, right? When you squeeze all this together, that little ring, the little tiny ring in the middle, there's a notch. There's a notch on that carrier, on that shaft, that ring fits into. A slotted groove. I need these two washers in there, definitely, and I need spring. So I can always take my old springs. I got some of my old ones here, and I got the old spring washer, which may be a little tiny bit thinner. You know, and that's just where I'm saying, like, it could be anything. You know, anything could work. So these are the 4051 spring plates. And these are the UC 4000 spring plates. There's an obvious difference in thickness and stack height. These are a little bit lower, so I'm hoping that I can just throw these on there and get enough spring out of the whole deal. That looks like it's gonna work, because if you think, if I push it down that much flat, it doesn't go down a whole lot. I mean, you're talking a millimeter or two. I don't know, because I'm not that precise on stuff. I mean, it only goes in those little tiny gaps. You're only looking at millimeters of difference. So it's not a whole lot that it needs to go in. It needs to have pressure. We know that much. It needs to push back hard enough on the entire unit that it's going to keep the hub from spinning free of itself. So now we have thinner spring plates, and I'm going to try pushing those. It's a clutch plate. I'll call it a clutch plate. That's the proper name for it. See, if we push that in, we have, right now, I'm just past the depth of the notch, so this should just slide right down. So I just have to get this ring over and slid down and clipped in, and then I think we're ready to rock and roll. But this is the tedious process here of using what I have available to do this. I could be here for a while. So I want to press that. You see it's just not going on. And once you get it exactly where you want it, it'll just slide right on. because you only have to get it slid out around that enough, and you don't want to bend it. You don't want to lose the spring in it. It's got to go over, down, and in the hole. I don't know if I can buy myself a little bit of room there. And it could just be having that much more room will help me to get it on. And there it is. Yeah. So it's just a matter of patience. It's really patience. And you just got to kind of outsmart the situation. You just got to get this to sit in that notch, and then as soon as you release the pressure, that plate, the one washer with the groove in it, will push against that. There it is. Alright, there you can see. There you can see I have it in the groove all the way around. You don't see the ring now. Right? You don't see the little spring-loaded clippy ring. Alright, and there I released it. I don't know if you saw it. Release pressure. There is a Makita saw hub modification. So here we have this saw. Alright, so there's that saw. It goes right on there and it stays on. If it comes off, we will know right away. Now, it should be a lot better for running this gouge because it does have more power than the little UC4000. Not as much as a gas saw, but it's got more torque. It's got more push behind it. It does have more rotational speed as well, I believe. Every little bit helps. I'm gonna get it tight, just see what happens. You can always go to Tractor Supply and get another belt for these. Now this is there we go. You hear it? You hear it getting faster. Something changed. I don't know what changed, but it's starting to, it feels like it's starting to adjust to its own environment, which is good. Sometimes they just need to get seated in. The belt needs to wear a certain way to the pulleys, or yeah, every saw is different, every setup is different. Sometimes they just need a little bit of adjustment time. So this is running faster now. It's messy here, guys. I gotta mow the lawn. I got so much I gotta do. It's all right. That'll burn out, or you can flip the saw. This is the most ideal setup for this tool. Yeah, I could get a little bit shorter belt, and because I have that room, I could slide the arm back. Yeah, if it was closer, a little more comfort there. Well, hello, Bumblebee. Also, if I change the cutting wheels, even spin them, because they are getting a little bit worked, a little bit dull. But the fact that I have this added to my collection now, A little dirt, a little oily rubber, never hurt anybody. The fact that I have this now on a dedicated saw. So this setup, this is great. It's not affected here by those thinner springs. You see, when I lay a carving down, it's gonna be like I'm going 100 miles an hour compared to what the saws do. I mean, I still like the saw detail, but I don't want to hit Mr. Bumblebee. He's working hard there. I don't want to disturb him. It's an awesome setup. It's only going to get better from here. This saw has all the power that I need to push that thing comfortably. It's just now it's just a matter of going to town, and you know, it's more about positioning. It's more about where I'm standing in reference to what I'm doing. You know, I could just lay them here and get them leaned up. And that's drier wood too. That's been sitting out all summer. This is, I think this was that piece of junk wood that I cleaned off real good. So this still has some moisture in it. Oh yeah. And I mean, you guys can hear it too. The tool itself, the blades, the blades are getting duller. They're getting louder. As they get duller, they're going to make more noise because it's more surface area dragging on the wood. But it's working great. More fun. We're still rebuilding saws. Still rebuilding. Still carving. It's still carving here and there. It seems like every time I go to carve, I gotta fix something. I want that much more. That's the fun of the business that I'm in, of always taking stuff apart. All right, well, we'll keep going here.